Alright, so with this video, we're going to show you how to do 4-point bend testing on our glass rods, and we're going to use a 4-point bend setup on this Instron 3382 mechanical testing frame, and we have it set up with a 4-point apparatus. So this video is going to walk you through the steps to operate the Instron in this configuration, to test our samples, and we'll go through it step by step. So bear with me as I sort of switch positions here. Alright, so let me walk you through our mechanical testing rig in the configuration that it is. So the first thing you'll want to notice is that there's actually a glass here. So this is a protective screen to protect you from anything that may come out during the test. So this has to be in closed position or the machine won't operate. So if I open it, I can kind of examine what we have with this testing rig. So we have a large load cell. It's 100 kilonewtons. If you might be able to, sorry about that, see that. But we also have attached to it in line a 5 kilonewton load cell, and that's what we're going to be using, a 5 kilonewton load cell attached to our 4-point bend apparatus. Just another note, we have a homemade sort of shield system here, one on the bottom and one on the top, and this again does another job of containing all the glass within this area. So we have that as well, and we have it so that we can remove it and put it back in place as we're running the test. Alright, so let's get a little bit closer of a view of the 4-point bend part itself. Alright, so hopefully you'll notice that we have basically our points of contact. So we have 2 points that are wider on the bottom, and then 2 points that are narrower on the top. So that's the configuration for 4-point bending. So as the test operates, the top portion here will come down and move in towards the other, and that will be the point where it starts to bend. So we've I brought this over so you can kind of see the dimensions of this. So part of the calculations that you'll do for 4-point bending will be the span lengths, and so the spans are how long these points are from each other. So on the bottom, so what they call the outer span, and then the inner span up here. And so basically this machine set up, I don't know if you'll be able to see it. Let me see if I can zoom in. So note where the line is here, and the same thing over there. And so I can also, just for point of reference, put a ruler up there. And so basically, you should notice, that when the label says 4 here, that's referring to centimeters, and so you want to have both on 4, so the whole span here is 4 centimeters between contact points. Sorry for the camera shaking here. And so the same thing we can look at for the top, and you should notice these lines at the 2 marks, right? So this top span is 2 centimeters. So we've got 4 centimeters at the bottom and 2 at the top. So that's the way we have this set up. Another thing while I'm down here, you might notice we have a aluminum piece machined here. And another piece back here. This is to keep a glass sample. I apologize for the camera work there. So I'll go back to this in a second. So I can insert a glass rod, and that will basically keep it from this piece over here and then the piece back here are to keep the glass rod from moving around. All right, so that's the span of this setup. So where the 4 contact points are. So those will be needed when you start to do calculations for 4-point bin testing. So we'll keep everything with this configuration that you see here. And so that's just a quick walkthrough of the actual instrumentation. So the 4-point bend apparatus, the load cell that you can see up here, and so forth. If we need to move anything, the controls are the same from tensile testing that you've seen in MSE 202 and other classes, or in tensile testing. So this jogs the crosshead, so the whole top portion, up or down. This is the emergency stop over here. So those are all the controls, and like I said, it won't operate without the door closed. All right, so in the next section, we will get a glass rod set up, and then I will show you the operation using the Instron software. All right, so I've got my glass rod, and I want to start by inserting it into the machine. So the first thing I'm going to do is, I've already opened the door. You saw the safety door. I've also taken off the front pieces to our little glass specific cage here. So I've taken those off. And if it's not set up already such that the glass can just barely fit in between the span pieces here, the contact points, what I want to do is I want to slowly bring down the top crosshead to a point where my glass rod will fit in between, but there won't be any contact, right? So it's just able to move around. The point here is if there's a lot of empty space between the contact points in your glass, the test will take a very long time. So that's why we want to slowly adjust this. And it's best to do that without the glass rod in there. Slowly move the jog down and then try the glass rod in again and see if it fits. This is the safest way to do that. So we've already got that part set up. So once we have that, what we're actually going to do is switch over to the software so that we can balance the force real quick before we put in our glass rod. So let's switch over and look at the software. Alright, so we're switched over here to the computer screen, and the first thing I want to just point out about this computer system attached to the Instron is that it is a touch screen. So you can click, and hopefully you can see that. So you can use that. However, we also have a keyboard and a mouse set up over here on the right. So sometimes we prefer just to use that. So this is going to be the desktop, and so the first thing we want to do our testing is open up this icon right here. So it's a little small for you to see, but it is Blue Hill Universal. Blue Hill is the Instron, the brand of the hardware, their software component. So we're going to either click on it with the touchscreen or double click with our mouse to open up this Blue Hill software. Alright, so it's opening up right now. It may take a second. You may hear a click, and that's so that we can actually operate with the software controls. And it will ask you for a username and password. Those are available in the test room, or you can ask the lab personnel to find out what those are. So this will be the home screen for the Blue Hill software. And so you'll see test, and I apologize for the glare here. Let's see if I can make that better. I cannot. So you can see test, method, and admin. So you definitely don't need to do anything with admin. And then we won't use anything with method, because this is actually going through and defining the method that we're going to use for a given test. So we've already actually set this up. But just to show you, we'll go to method, and then there are templates and methods. And so one of the methods down here is the 4-point bend glass. So that's going to be the one that we use for this experiment. And so it's opening it right now. So this would actually allow us to change it. And so typically, as a student in the lab, you're not going to need to change this. But just for future reference, you can go up and look at all these various commands and set up a routine so that the user can easily set this up. And so we have the support spans in the setting. We have the type of material. We have all the kind of conditions. We can control the test. And so the one thing I kind of wanted to point out here is the strain rate that we're using for this test, which you might be able to see there as 0.5 millimeters per minute. So that's the speed that the crosshead's going to come down and that we're going to test this glass. So I definitely wanted to point this out to you in this. Otherwise, we are basically moving the crosshead down so that this test operates in kind of compression mode, but since we're dealing with a 4-point span, it will be under 4-point bend strain. So let me go ahead and get out of here by hitting the home button. I don't want to change anything, so I'll hit no. And then we're back to the home screen. So we're actually going to just do test. And so I'm going to hit test. And then now I'm going to open up the method that we just looked at. So the 4-point bend glass. It should have a little icon of something bending. And so this is the actual test. So it will leave you, it will give you instructions over here, and then you can input your data over here. So this that we're testing right now is the flake glass. We sanded it to 400 grit and ion exchanged in KNO3 at 400 degrees C for 2 hours. So this is just giving you kind of an idea of the sample that we use. So try to give as much information as you can in this field, and then you can name it down here in this box. And so we'll call this sanded, I'll call this KNO3. So, you know, whatever naming convention works for you, that works. And then the folder, we click over here, we're going to save this to the desktop, and then we have an MSE 407 folder, and so we're going to save it there. So I'm going to hit select down here at the bottom. Alright, so I've ID'd my sample, I put the sample name and the location of where it's going to go, and then I'm going to hit this button down here, and let me see if I can get a better view of it for you. Not much better. The lighting in here is pretty bad. There we go. So the before test. I'm going to hit this button. Alright, and it'll take us to a new window. And I'll read through the instructions up here if you can't see them. But basically it says follow the instructions here. We're going to input the value. So the only value we have to input over here is the diameter. So this is what you're going to read off from your piece of paper that you filled. And so the diameter was 5.03 for this glass rod. So I've inputted that. Then it's telling you to wear safety glasses. So I've got my glasses on right now. Then it says to zero load and displacement. And so this is one I'll probably have to zoom in here for you. So down here, way at the bottom, you'll see balance force and zero displacement. So I want to balance the force. So if you go back up here to the top, it says force in newtons. Right now, nothing's happening. There's no glass rod in there, but you can see that there's already a 1 Newton force on it. So I'm going to go back again down here, hit this balance force, and you'll see it kind of set up there. And then now it's basically 0. So there might be a small value, but keep in mind this is in newtons, and so that's a pretty small number that we see. I've also, if you see any displacement, you want to zero the displacement down here as well. So I'll hit that, and that should zero it out up there. And so you'll want to make sure that you have it zeroed after you have everything set up. So once I have the force or load balanced or zeroed and the displacement zeroed, I'm going to go ahead and put in my glass sample. So I'll cut here and I'll show you how we put the glass sample in. Alright, so let's put the glass sample into the apparatus. So again, I've got the glass sample. It may be hard to see here, but I've got that line. So I'm going to make sure that line with the piece of tape is oriented up. And so I'm going to insert through the spans. And I'm going to make sure that that line is facing up and that the tape is in the middle. Alright, so I've got both of those, and the glass rod is in place, and it's also against those supports that allow it to keep it from moving from front to back. So that's all set up in the test rig, and so I'm going to go ahead and put the glass pieces, the plexiglass, back in place. And I'm going to close the door, the safety door. Alright, and then we are ready to go. So I'm going to switch it back over to the software and we'll start the test. Alright, we've got the sample in the test rig and we are ready to go. And so I'm going to finish reading off the instructions up here. So we zeroed the load and displacement, put our sample in, and it just tells us to keep clear of the machine. So we're doing that. We've got the screen in place, and it basically tells us to start, hit the start button when we're ready. So let me zoom in real quick to show you down here in the bottom right, there's a start button. And so this will start the test. So the crosshead will start moving down, and then we'll start to see a display here that shows the graph, the force, the force versus displacement curve. So I'm going to hit start, and I'm going to zoom it back out so that you can see the screen here. So this is the graph that I'm talking about. So hopefully you can see that. The bottom here is displacement, and then this is stress. And so we should start to see that when we make contact. It may take a few seconds to make contact. Also, up here, you can monitor the displacement and the force to make sure everything is moving. So I'll try to show you all of that. So if it does take a while for it to initiate, for it to make contact with the glass slide, that might just mean that the top span is far away from the glass, so it might just take a little bit longer. And so that's something you can always go back and adjust. And so here you just saw it kind of shoot up, the force went up, and then we see the curve here as well. So you might see an initial kind of sloppiness. So that's as it starts to make contact. But here you can see the force is going up, and it's much more linear. All right, so you probably heard that. That was the glass breaking under the 4-point bend moment. So I didn't show you the actual test because you can't really see much happening with that without having a high-speed camera and so forth. So I just wanted to show you the curve that you see here, and then at the end you see the max force. That's where it breaks, so it kind of auto detects where that happens, and you can also kind of again track the displacement and the force up here. And then here the table down here keeps track of the measurements for you. So we have a max flexural load, and it gives you the extension at that load as well. So this is the 737.36. So we're going to write that number on our piece of paper that we have for calculations. So after this is done, so that's done now. So what we want to do is remove the sample. So I won't show you that, but essentially we want to remove all those pieces from the test area, and we want to collect all of those, and then I'm going to show you what we do with those in the next video. So right now, basically, what I'm going to do is I'm going to show you how we go to the next one. So let's assume that we just cleaned up all the glass and we're ready to take to test the next one. What we want to do here is click down here. It says test notes. So this is the next screen. And so this basically just gives us some options to make some observations. So we can write what kind of behavior. So yield or rupture. So I'm going to hit rupture. And then if I want to make any comments, I can add them here. And then we can go right into testing the next sample. So when I hit the next button down here, it says before test. So if I click this, it's going to basically start the screen over again. So we're basically back up here at the same screen we had before, where we input the diameter, and then we can go through the whole procedure again to test the next sample, and it'll all be compiled in one data file for us. So that's the way you'll want to do a batch of these samples. All right, so that's how we test the samples, and then here in a second I will show you how to export that data. All right, one more quick note before we go on to data exporting. After you take the big chunks of glass away, take some type of broom or sweep and make sure you clear any sort of debris away from the spans and the workings here. So you don't want any sort of like glass pieces that are going to make contact with your next sample. So we just want to make sure everything is clean for those purposes. But the case here is basically to help us collect all of those pieces. So just a quick note to do that before you move on to the next sample. Alright, so let's go ahead and look at how we export our data. So the first thing we want to do when we're done with the sample is we want to hit the finish button up here. So you see the little checkered flag. So we want to make sure that we hit that. So that tells the program that we're done testing for that experiment. And then this option down here basically asks us if we want to test a new set. And so I'm going to hit no because I want to save the data. And also another thing asks us if we want to change the test method. So I'm going to hit no on that as well. So I'm back here to the home screen. And so we have saved it automatically saves our sample. But if you need to open it up, it should be down here where it says choose the sample. And so under sanded KNO2. So this just opens up what you tested before. So I'm going to minimize this, and we're going to go to the file that we created. So up here is our MSE 407 folder, and here in the folder you'll see there's a set of files that say sanded KN03. So those are the sets. It automatically saves them for us. There is a proprietary file to open in the Blue Hill software. There's a PDF that I can open. Sometimes it shows some data here, but basically don't really worry about that. The important ones for us will be these two CSV files. So if we open up the first one, it will actually display that summary table that was in the software, and then the second one will give us the raw data, things like displacement and force. And so these are what we can plot to show the curve and to do calculations. And so what I'm going to basically do is I'm just going to take all those files, and then I'll be able to have a backup of those. So what I'm going to do is, let me kind of back up here a little bit. In the back of the instrument, you should be able to see an extra cord, so we can actually hook up some type of USB device. So our lab has a bunch of lab USBs for us to use, and so I'm just going to go ahead and put our USB and then download those files that I just showed you into that USB. And so that will allow me to take it to my own computer and work with that data. So we are going to do the same procedure and upload those to the Google Share Drive for you to analyze that data. Alright, so that is what we need to know to operate the full-point bend test for these glass rods for this test. In the next video, I'll show you what we do with the broken fragments of the glass rods and a little bit more on that.